The second type was where we had infinity a little different way, right? It was 0 to 2, 1 over x minus 1 dx. I think I might have had squared there. Why is this one improper? Improper because of the discontinuity there. The discontinuity is 1, right? Well, that just so happens to be part of my limits. I think it was 1. It was x, 1 over 1 minus x squared, wasn't it? Was the one I did. But anyway, this is improper because at the discontinuity is captured in my limits. Okay? So sometimes it might take a little some to think about there, but you know, if it was 2 to 3, we'd be talking a totally different thing. If it was 2 to 3. Sometimes though, what about this one? Why is this one improper? So this one's improper because 1 is included in the limits. And it's undefined at 1. Same thing here, isn't it? Except it's not in the middle of it. 0 to 1, we're including 0, which the function is undefined at 0, isn't it? Yeah. Improper because 0 is included.
In that other one, wouldn't you just be able to get around that by going 1, 2, 1?
That's what we're going to do, yes. We are going to, yeah, we're going to do this one, yes. We are going to go 0 to 1 and then 1 to 2. That's the way we're going to do this. This one, we'll start with this one. Let's do this one first. I don't know if that's, I do a little different one, but it's the same idea on that one. Yes. Good call there. Okay, so here we go. Let's take the integral 0 to 1. I think this one just had 1 over square root of x dx. So again, 0 is my problem child, if you will, right? I can't plug in x to be 0. It's undefined. So that's what I do for my t limit. I don't go t to infinity, I go t to 0. So the t limit here, I do the limit as t goes to 0. And you might note here, since we're going to a number and we've got the infinity and negative infinity thing, might happen something different on either side. We are going 0 to the right. We are going at 0 from the right. You might note of that. Make note of that, because sometimes it does make a difference. If it was negative 1 to 0, that would be 0 from the left, right? Correct? Okay. All right, so we got the integral t to 1 now, 1 over square root of x dx. Okay. Well, here, this is just how I do that. That's x to the minus a half, isn't it? So the integral antiderivative would be, minus a half plus 1 is going to be positive a half. And so the reciprocal 2 over 1, and then I go t to 1. So we got the limit as t goes to 0. Is that right? Did I do that right? 2x a half. Does that sound right? That's what I got on my paper too. So seems right. Okay, so going x is 1, so it'll be 2 times 1 to the 1/2 minus 2t to the 1/2. Now I can do the limit. If you're okay with that, plug in your limits. Well, 1 to the 1/2 is 1, so this is 2 times 1, that's just 2. T is going to 0 from the right, which it doesn't really make a difference here. I guess it does. If we were going from the left, it wouldn't be existing. But 0 from the right, for that, what does that go to? 0 to the half, which is 0. This is going to 0. 2 minus 0, it's 2. So even though this function doesn't exist at 0, I can still do the integral because it's more of a limiting type thing. With me? That's kind of a different thing than we were doing, but it's sort of the same thing. You can never go out to infinity, but you can calculate the area under the curve to infinity because it's a limit. All right. What about? Okay, so yeah, we'll do one with one in the middle here in a second. Let's do 0 to 1 integral 1 over x minus 1 to the 2/3 dx. Okay, I do this one because where's this one, the problem occurring, if you will? Well, it's not defined at 1. But 1 is one of my limits. So I can't evaluate this at 1. So I'm going to have to do my t limit. I'm going to do the t limit as t goes to 1. And this would be which side? From the left. Yeah, I'm going 0 to 1. So I'm going to approach 1 from the left. 0 to t, 1 over x minus 1 2/3 dx. So I'm going to do that integral. Very carefully, yes. All right. How about we change it to x to the minus 1 to the negative 2/3. And then it's basically just power rule because it is u substitution, but if your du is dx, it's basically just doing your power rule there, isn't it? Because there's not a factor of anything of note there, and there's nothing to cancel. It's u to the minus 2/3, basically, du. If you have, write it all out if you want to, but it's just going to be power rule. Add 1, which would be 1/3. Reciprocal up here, 0 to t. So I'm going to have 3 t minus 1 to the 1/3 minus 3, 0 minus 1, so it'll be minus 1 to the 1/3, right? Plugging in t and 0. Well, this is the cube root of t minus 1. T going to 1 from the left. What is that going to go to? It's just going to be plugging in, right? I can plug in t there. T. What do I get x? Bad limit there. Okay. These should have been t's. Make sure you change those to t's. I said x's. T is going to negative 1. T is going to 1 from the left. I'll say it right here yet. It's been a Monday today instead of Friday. I'm recording this on Friday, but it feels like a Monday. Friday's supposed to be good days, yeah. It's been a long week. Anyway, okay. T is going to 1 from the left. It doesn't matter because I can just plug it in, can't I? T is going to 1. 1 minus 1 is 0. Cube root of 0 is 0. That's 0. Any way you slice it, that's 0. That's going, well, that's the cube root of negative 1, which is negative 1. So I have negative 3 times negative 1. That's positive 3. This limit is 3. The integral is 3. How about that? Believe that? Came out really nice. Okay? All right, let's look at our 1 over x again. Just thinking it didn't turn out too good with an infinity. Let's see. I think this is what you were talking about, Josh. What if you go in that little part between? Well, sometimes it works out. Well, let's see if it works out for 1 over x. Oh, let's do this. Sorry. Negative 1 to 0, yeah. You get it works basically the same for 0 to 1, but let's do 0 to negative 1 to make. I think there's an ultimate point here, but okay. So our problem, what am I going to do with t? T goes to 0. Limit t goes to 0. And we're going from negative 1 to 0. So I'm going to approach 0 from where? Left? 0 from the left. And that's going to be then the integral negative 1 to t 1 over x dx, which we just did. 1 over x, that's natural log, so it'll be the limit. T goes to 0 from the left. Natural log of absolute value of x, which is going to play a role here, which I guess is why I did the negative side, so the absolute value does come into play. Okay, plug in. Is that all right with me so far? Okay, so that's the limit as t goes to 0 from the left. Natural log of absolute value of t minus the natural log of absolute value of negative 1. Well, let's handle this one first. Natural log of absolute value of 1. Well, that's natural log of 1. Natural log of 1, that's 0. That's 0. What about, though, this? Well, t is going to 0. So I'm talking natural log of 0. Well, can you do natural log of 0? No. Can't do natural log of 0. So that's where you want to think about your graph. Now, it's the natural log of the absolute value of t. Why is that significant? Because if I just do the natural log of t, that's only this side. But if I do the absolute value of t, that gets me both sides. You see? So I do have something on 0 to... There's something there. Now, what happens as I go towards 0 from the left? As you approach 0 from the left, you might have to graph it out, but look at it, see what happens. What's it doing? Minus infinity. Yep, this is a divergent integral because it goes to minus infinity. So there are minus infinity ones out there.
What happens if you're creating a function between the limits? If you're going to negative
We'll do that one. All right. Okay. Have I touched that one yet? I'm doing 1, 2. Yeah, I got 2 more. Let me do one more without the one you're talking about there. All right, so let's say we've got, again, negative 1 to 0, 1 over x squared dx. We just saw, the very first one we did, I believe, was 1 to infinity, 1 over x squared. Well, does it make a difference if we go negative 1 to 0, 1 over x squared? Because there's still a problem there, isn't there? The function's not defined at 0. So this is why this is improper. I've got to do my t limit as x goes to 0, t goes to 0, from the left, again, because I'm going negative 1 to 0, so that's 0 from the left. 1 over x squared dx, and it's negative 1 to t again. Well, that's x to the negative 2, so I can just do a little power rule there, antiderivative power rule. It'd be what? Negative 1, what was it, negative 1 x to the negative 1? Believe that, negative 1 to t. Zero from the left. All right, so it'll be negative t to the negative 1 minus negative 1 to the negative 1. Okay. Be sure you get all those negative 1s in there. What have I got? A lot of parentheses. Yeah. I think this, actually, that's negative 1. Then I've got a positive 1, but then it's behind another. I think it's just minus 1 here. This goes to minus 1. But I don't think that's going to amount to a whole lot. Because, what about this? Well, let's think about, all right, so this is 0. All right, so it's negative 1. Let's rewrite this as negative 1 over t. And this is minus 1. Well, when we were running t to infinity, this was 0. But is that the case here? No, because I'm going, t is going to 0 from the left. 1 over t, negative 1 over t. If nothing else, like I said, just graph this part of it and see what happens as you go to 0 from the left. Negative 1 over t, I think we are that. That's looking like infinity. That's looking a lot like infinity, isn't it?
That would be the same as if we made a table.
It's infinity minus 1. Yeah. Look at a table. Sure. Think about the graph or a table. Sure. So infinity minus 1. Well, that's infinity. Okay. That's not indeterminate. Infinity minus 1 is infinity. Well, I guess it's somewhat indeterminate because infinity's, what is infinity? Who knows what's infinity? Who's out? Nobody's out there at infinity. Okay, so yeah, that part right in here, and I think it is the same from 0 to 1 too, but that little part right in there, you can't do, I mean, it looks similar to what we did a while ago with this piece. We went here to here, that was 1. Here to here, though, that's infinity. Don't think about that too hard. It'll blow your brain. Why? That's for the philosophers, I guess. No, it has to do with the powers, and we'll do this kind of another angle later on. But
this is actually making somewhat sense.
Good.
Yeah. So I'm not going to ask why.
Okay. Don't push it too far, huh? All right, here you go. 0 to 3, 1 over x minus 2, 3/5. Last but not least. Definitely not the least. Okay. All right. Here, 0 is okay. 3 is okay. What's not okay? 2 is not, which is between 0 and 3. If I wasn't going through 2, this would be no problem, right? It would just be power rule. If this was 3 to 5, I wouldn't have to do any of this that I fixed it to. But since it goes 0 to 3, and I've got a 2, x equals 2, it's undefined place. What am I going to do? Well, this is like the negative infinity to positive infinity thing, sort of. I'm going to split this up. I'm going to go 0 to 2, and then 2 to 3. Because then I can do my t-limit stuff with that. Let's go write that. Where's my dx? Dx should be in there somewhere. Okay. Now I have to do my t-limit stuff. So I'm going to do the limit as t goes to 2 here. And it's 2 from the left. 0 to t then. And let's go ahead and just write that. cut to the chase here. That's x minus 2 to the minus 3/5 dx. Then on the second one, I do my limit as t goes to 2. But in this case, it's 2 from the right, because we're going from 2 to 3. So I'm approaching 2 from the right there. So that's t to 3 of x minus 2 to the minus 3/5 dx. Okay? So far, so good. All right, so we've got the limit. T goes to 2 from the left. What about that? Yeah, it's just power rule. Again, you know, if it was x to the minus 3/5, yeah, that's direct power rule. And this is the same thing because your du equals dx. If you let u equals x minus 2, then du equals dx. So there's not any factor, anything I have to even factor in there. So it's just, yeah, power rule. X to minus 2, add 1 to that, you get 2/5, don't you? And so what's up here? 5/2? And I'm going to go 0 to t. Here, same thing. Limit, though, t goes to 2 positive. So it'd be x minus 2. Yeah, it's the same one. 2/5, so it'd be 5/2 here. T to 3. See what happens. Plug in my t and 0. So that'd be t minus 2 to the 2/5 minus 5/2 negative 2 to the 2/5. Then over here, I'll have the limit t goes to 2 from the positive side, so that'd be 5/2. Plug in 3, you got 1 to the 2/5, which is 1. And then minus 5/2, squeeze it in there, t minus 2, 2/5. Okay. So now I just need to do myself a couple of limits. No problem. This is just a number. It's negative 2 to the 2/5. That's a number. It's not a very nice number, but it's a number. Because it's the 5th root of negative 2 squared. So it's 5th root of 4. Basically there. In actuality. But then it becomes, what happens here? T goes to 2 from the left. Huh? Well, this one, yeah, okay, let me say something about that. Since it's a 5th root, it's going to be defined everywhere. An odd root is defined everywhere, right? You know, the odd roots are the ones that go like this. The even roots, you know, you got your negative sides you don't have, you know what I'm saying? This is an odd one, though, so it goes both ways. You see what I'm saying? Okay. Well, t is going to 2. And since that's just a number, okay, I mean a positive number, just plug it in, isn't it? Can I just substitute in? Yeah. Because this is defined on either side. That's why I was saying that. If this was 5/2 power, yeah, we run into a problem going 2 to the right, 2 from the left. But since it's an odd root, you can look at it, whatever, but t is going to 2, so that's going to 0. This is going to 0. We have 0 to the 2/5. 0 to the 2/5 is 0. 5/2 times 0. That's going to 0, okay? All right, what did I say this was? 5/2. You can write it 5th root of negative 2 squared. So it's 5th root of 4. Scare me there. Okay. Sorry about that. All right, then this, 1, so that'd be 5/2 there. What about that? Well, again, t is going to 2, so 2 minus, that's 0 again. So we get, yeah, minus 5/2, 5th root of 4, let's just call it, minus 5/2, or plus 5/2. Yeah, you could factor, a 5/2 out and make it 5th root of 4 plus 1. Whatever, yeah. If you so desire. Sure. 5 halves, so that would leave me minus the fifth root of 4 plus 1, if you so desire.